Sequences in series, arithmetic sequences, type 1, establishing a general term. So we saw yesterday when we were looking at our patterns that when we were looking at the list of numbers, we could see that there was a common difference between each of the numbers. So if we have a look, for instance, at this list of numbers here, 4, 11, 18, 25 and 32, we can see that there is a difference of 7 between each of the terms. So we could write this list as the first number plus the differences. So the first term is 4. The second term is 11, which could be written as 4 plus 7. The third term is 18, which could be written as 4 plus 7 plus 7. 25 can be written as 4 plus 7 plus 7 plus 7. And 32 could be written as 4 plus 7 plus 7 plus 7 plus 7. And we could keep going on like this, and obviously we'd get very messy because we'd have a lot of 7s. So let's make a table. So in the table, if we list them as term 1, that's going to be 4. Term 2 is 4 plus 7. Term 3 could be written as 4 plus 2 7s. Term 4 could be written as 4 plus 3 7s. Term 5 could be written as 4 plus 4 7s. And if we get all the way down to the end, we could look at writing what would term n look like. Well, if we look at the term position, we can see that we have T1 is 4, T2 is 4 plus 1 7, T3 is 4 plus 2 7s, T4 is 4 plus 3 7s, T5 is 4 plus 4 7s. So what we should notice is that the term position, the number in front of the 7 is always 1 less. So in other words, if we were to look at T of n, we would expect that to be one number less than n times 7. In general, what we say is that the first term is actually referred to as the letter A, and the plus 7 is referred to as the difference between the terms. So in other words, we say that A is the first term, which is also referred to as T1, and D is the common difference between each of the terms. And that's what an arithmetic sequence is. It's where we have a common difference between every single term. So a fixed number added to the previous term will get you to the next term. So therefore that can be written as term 1 would be A. Term 2 is A plus D. Term 3, A plus 2D. Term 4, A plus 3D. Term 5, A plus 4D. And of course, the general term then would be A plus n minus 1 times D. So we say that to find the general term for any arithmetic sequence, our formula is A plus n minus 1 times D. Now, of course, if we go back to this one here, that can then be simplified to be written as T of n is equal to 4 plus 7n minus 7, which of course is 7n minus 3. So if I sub in any value for n, where n is a natural number, then we could find any number in that arithmetic sequence. Now, of course, if we go to our maths tables and we go to page 22, we can see that we have arithmetic sequences in the top half of the tables, and we can see the general term right there, T of n, is A plus n minus 1 times D.